The paper we are solving today is IGCSE Physics May June year 2024 and it is the MCQ paper extended version. Alright. Now the first question, it mentions that a student wishes to measure accurately the volume of 40 centimeter cube of water. We have two options. We can use a cylinder 100 centimeter cube or a smaller one that can hold up to 50 centimeter cube. Then there is also a mention of meniscus. The top meniscus is there, bottom meniscus is there. So for meniscus it is very simple. We know that the bottom meniscus is preferred because it is always more accurate when measuring the volume. So we will pick the option which has bottom meniscus as the answer. So according to that, C and A both have bottom of the meniscus. Now we will have to differentiate whether you are going to use the larger one or the smaller one. So for measuring cylinders, the smaller the measuring cylinder is, the more accurate and precise the measurements will be. So which option should we go with? We will go with option number C. Okay. Now, next question. The motion of an object is represented by speed time graph as shown, and then they specifying that this is the area under the graph. Question is asking which quantity is equal to the area under the graph. Options are acceleration, average speed, distance traveled, kinetic energy. So this question is on the simpler side. We know that gradient of speed time curve gives acceleration, but the area of speed time curve gives the distance traveled. And are they asking about the gradient or the area? They are asking about the area of speed time graph. So that will be the distance traveled. Similarly, let's say if this was an acceleration time graph. So if you take area of acceleration time graph, it gives you change of velocity. It gives you change of velocity. So if in place of speed time they had given that this is acceleration time graph, then the answer would be change of velocity is represented by area of acceleration time graph. Okay, now next question. There's an astronaut with a mass and he's on a planet with a gravitational field strength of 3.8 newtons per kg. So this question is fairly simple. As we are aware that weight is equals to mg, and on earth, let's say if my mass is 80 kg and the gravitational field strength approximately is 10. So on earth my weight will be 800 newton. This is on earth. But now he is on any other random planet. So what will be its weight? Weight will be mg again. Mass you will use as 80 and g they have specified, so you have to use this 80 times 3.8. So the answer approximately will be equal to 300 newtons. Next question. There is a sealed container of volume 2000 centimeter cube which contains air. So the volume of air is 2000 centimeter cube. Alright. The container is placed on a band balance to measure the mass and the mass comes out to be 200 grams. Point to be noted. Then they are removing the air by a vacuum pump. Now the balance is showing 196 grams. Initially with the air it was 200 grams. Now when you remove the air it is 196 grams, right? So what is the mass of air? Mass of air will be 200 minus 196, that is 4 grams. Now what are they asking us? What was the density of the pressurized air? So density is mass over volume. What is the mass of air? 4 grams. What is the volume of air? 2000. Now if we solve this, 4 over 2000, 4 divided by 2000, that is nearly 0.002 grams per centimeter cube. So answer is A. Now next question. Each diagram shows 3 forces on a beam. In which situation is it possible for the 3 forces to be in equilibrium? Now for equilibrium there are 2 points in our syllabus, that net force should be 0 and net moment should be 0, or you can say anti-clockwise moment of force should be equal to clockwise moment of force. These are the overall 2 points that we need to take care of. Now, option A, this doesn't look like the moments will be balanced because majority, both of the forces are acting towards the right. So it will most likely rotate like this. So this is not an equilibrium. Now, option B, this will get cancelled out. Option C also doesn't look like it, and it will most likely rotate anti-clockwise. Option D, on the other side, this is some force F1, F2 and F3. So this combination is a possibility that the sum of these two, F2 and F3, comes out to be F1. This is a possibility. And the moment can also be 0 because one will be clockwise, the other one will be anti-clockwise. So option D is a possibility. So we will go with option number D. Now, next question. A gymnast jumps down from a high piece of apparatus. She gradually bends her knees as she lands. Okay, we have seen this in multiple sports. People bend their knees, or sometimes that when a cricketer is catching a ball, when he touches the ball, he pulls his hand back towards his body. Why do they do that? Let's see. Force is equals to mv minus mu by t. So, the greater the time of impact, less force we will feel, right? There is an inverse relation between force and time. Greater the time of contact, less force will be experienced. This is why there are airbags in the cars. What they do is they increase the time of contact so that force experienced will be less. Seat belts also help in that. They increase the time of contact so that force will be less. Similarly, cricketers do the same thing. When they catch a ball, they bring the ball towards their body. They bring their hands catching the ball towards their body while catching the ball. Why? To increase the time so that force reduces. So which option is mentioning that force will be reduced? She will experience a smaller force from the ground as she lands because she is increasing the time of contact. So answer will be D. Now, question number 7. The table gives 4 energy sources and states whether the main source of energy for the resource is the sun. Which row is correct? Geothermal is the main source, sun? No. Oil, the main source is sun? This is also no. Incorrect question. Incorrect answer. Water held behind a dam, is it due to sun? That sun is somehow controlling how much water holds in a dam. Yes. And wind. Is wind controlled by sun? I don't think so. So the answer will be C. Water held behind a dam, the main energy source is sun. Next question. This equation, change in pressure is equals to, so this equation is change in pressure is equals to density times gravitational acceleration times change of height. They are simply asking what is this symbol. This symbol is called as rho and it signifies the density of the liquid. So the answer will be B. What are the correct terms for each change of state? Liquid to solid. So that will be solidification. So option A or C. Now liquid to gas. That will be evaporation. So answer correct will be C. Now question number 10. Extremely small pollen grains in water are viewed through a microscope. The grains are seen move continually and randomly. So this answer, what is the reason for this random movement? The grains are moved by randomly moving water molecules. This is correct. The grains are moved by random convection currents in the water. How do we know whether convection currents are there? Are you heating the water? They have not mentioned it, so we'll have to ignore this. The grains are moved by random rays of light reflecting off them. Rays of light are not that powerful to move something. The grains are moved by the random motion of their own atoms. So it is suggesting that the grain, which is made up of millions of atoms, billions of atoms, due to motion of their own atoms, the grain is moving. Not a possibility. So the answer will be A. Now, question number 11. Which graph shows how the volume of a fixed mass of gas at constant temperature varies with its pressure? So, constant temperature is the keyword, and from this we can identify they're talking about Boyle's law, or you can call it, let's just call it Boyle's law only. The relation is that PV is equals to constant. So pressure will be inversely proportional to volume. Is this an inverse graph? No. This is a directly proportional graph? No. Is this an inverse graph? No. This looks like an inverse graph. Yes. So this is our inverse graph. As pressure increases, the volume decreases, and as the volume increases, pressure decreases. So this is the best fit. Now, next question. The temperature of the water at the bottom of a waterfall is greater than the temperature of water at the top. The energy in the gravitational potential store is transferred to the thermal store. Okay, so they're simply telling you that the gravitational potential energy converts to the thermal energy. What is the formula for gravitational potential energy? mgh, and the thermal energy will be mc delta T. They have given you the specific heat capacity and they are asking the temperature difference. So what are they asking? They are asking delta T. How do we solve this? mgh is equals to mc delta T. We can cancel out the m. G, let's say I'm taking 10 and height is 21. C, specific heat of capacity, specific heat water capacity, so that is 4200 into change of temperature. So 10 into 21 over 4200 will be delta T. Let's calculate how much is this. 10 times 21 is 210 divided by 4200. So this is coming out to be 0.05. Now, is there any option which says 0.05? This is 0.005, but our answer is 0.05. So this is not the answer. 0.049, and this can be rounded off to 0.05. So this is the answer. Next question. An ice cube is placed in a beaker and heated. The ice melts to form water, which evaporates at first. The steam condenses on a cold window in the room. Okay. Which process involves a transfer of energy from ice to the surroundings? So they're simply asking which process involves decrease of energy, because when energy will decrease, only then that energy will go to the surroundings, right? In melting, you supply energy to melt. So this is not the answer. Also in evaporation, the liquid is converting to steam. So you're supplying energy. It is not decreasing energy. In boiling as well, you're supplying energy. However, in condensation, the liquids have more energy. Changes to a solid, solids have less energy. So where is this energy going? This energy is going to the surroundings. So D will be the correct answer in this case. Next question. A teacher shows his class a polystyrene cup. So polystyrene is a bad conductor. It traps air. We have already studied this. The polystyrene is a thick plastic with lots of tiny air bubbles in it. He asks the class why the cup is a good at keeping the hot drink warm. So bad conductor. It does not allow heat transfer. 3 suggestions are made. It contains air, which is a poor thermal conductor. Correct. Air traps the convection currents. So air is trapped in tiny bubbles, so very little convection is possible. This is correct. Plastic itself is a poor thermal conductor. Correct. So the answers will be 1, 2 and 3. Two samples of the same material have the same mass but different surface areas. Okay. Each sample is heated to the same temperature and then left to cool at the room temperature. Each sample is allowed to cool to the same final temperature. So the change of temperature is same. There is one with a smaller surface area, there is one with a larger surface area. So in the one with larger surface area, we know that the processes take faster. Energy transfer will be faster. Okay. Energy transfer will be faster, but ultimately both of them are reaching the same temperature. So think about it. They were at T1, then ultimately both of them are reaching at T2. Alright. So the total change in energy is same, because ultimately they were starting at T1 and they are ending at T2. So the change in energy is same. However, one of them has more surface area, so it will undergo the change faster. It will lose the energy faster, but ultimately the change will be the same. It's similar to rate of reaction. They were initially starting at same temperature, reaching the same temperature, so ultimately the change of energy is same, but there is one with larger surface area which will lose energy at a faster rate. Alright, so x will lose energy at a faster rate, so y has a large surface area, so y will lose energy at a faster rate. So y cools down faster than x and both lose the same quantity of energy. So option D will be there. I'm repeating this again. They started at the same temperature, they are ending at the same temperature. So the change of energy overall is the same. However, there is one material with larger surface area, the other one with smaller surface area. So the one with larger surface area, which is Y, will undergo this transition at a faster rate. It will take less time. That is why option D is correct. Question number 17. In which type of wave, direction of vibration is parallel to the direction of wave? So when vibration is parallel to the direction of wave, that type of wave is called as longitudinal wave. When it is perpendicular, that is transverse. And seismic P waves are longitudinal in nature. EM waves are transverse. Seismic S waves are transverse. Water waves, they are sometimes longitudinal and sometimes transverse, depends upon the depth. So we will discard water waves. Seismic P waves will be the best option. So option B will be correct here. Now, waves in a ripple tank are diffracted as they pass through a narrow gap. Okay. What can be done to make the spreading due to diffraction greater? So what we are trying to do is we want more diffraction. Alright. As we know that if you increase the wavelength, there is more diffraction. And if you decrease the gap size, more diffraction will be there. So we have to pick one option which is suggesting increase the wavelength or suggesting decrease the gap size. Decrease the frequency of the waves, keeping the speed constant. Now, what option A is suggesting is that V is equals to F lambda and you have to keep V constant. So if V is constant, frequency will be inversely proportional to wavelength. If you are decreasing frequency, wavelength will be more. So this option is indirectly suggesting that increase the wavelength. Speed is constant, then frequency will be indirectly proportional to lambda, right? So if you are decreasing the frequency, wavelength will increase. So now I already know the answer. Answer will be A, but let's check the other options as well. decrease the speed of the waves and keep the frequency constant. If you apply this here, V is equals to F lambda, they're saying keep this constant. So V is equals to constant into lambda means V directly proportional to lambda. If you're decreasing V, you're decreasing lambda. This option is wrong. Increase the frequency and keep the speed constant. V is equals to F lambda. Speed, if you're keeping constant, then frequency will be inversely proportional to lambda. And if you're increasing the frequency, wavelength will decrease. Incorrect option again. And again it is mentioning increase the frequency, so that will be incorrect again. So we've discussed all the 4 options in detail and the option A was the correct one. Now, question number 19. Diagram A shows the page of a book in front of a plane mirror. An eye is looking at the image of the page. The diagram 2 shows letter G on the page facing the mirror. It is arranged like this, but what is the appearance of the image? So it just gets twisted, rotated like this. So the answer will be D. Answer here in this case will be D. Now, question number 20. The diagram shows a ray of light passing from air into the diamond. Okay. What is the refractive index of the diamond? So, we can solve this question using Snell's law. What Snell's law says is that N1 into sin I is equals to N2 into sin R. What is N1? This is your N1. This is N2. N1 is air. Air's refractive index is 1. And what is the angle of incidence? You draw a normal from here. Angle of incidence will be 30 degrees and angle of refraction will be 12 degrees. So you put in the value sine 30 is equals to refractive index of diamond we are trying to find out. Okay, so leave it as it is. And sin R will be sine 12. So when you substitute these values, let's try. The answer will come out to be 2.4. You just need to rearrange this. Just simply do sine 30 over sine 12. And if you simplify this, the answer will come out to be 1.2. So 1.2, it will be 2.4. So the answer is C. Question number 21. They're asking which row describes the image produced in diagram 1 and diagram 2. Diagram 1 is the 6th case, the last case for convex lenses, and we are aware in this that when the dotted rays are formed, so these are virtual rays. So the image formed will be virtual, and if dotted rays are not there, the image formed will be real. So answer correct will be option number C. White light enters a glass prism. The light leaving the other side of the prism is separated into 2 colors. Okay. Which row correctly describes what happens? First of all, when this type of diagram is there, we need to be knowing that the order of the colors is like this, Vib, Gyor. So the bottommost color is violet because the frequency is the highest. If the frequency is highest, it bends the most, or you can say it refracts the most. Point to be noted, students, the color or the radiation with the highest frequency undergoes highest refraction. So the bottommost color in these type of diagrams will always be violet, then indigo, then blue, then green, then yellow, then orange, then red. So the order is violet, indigo, blue, green, yellow, orange, red, bottom to top. Okay. Now, in diagram 1, the color 2 will be violet, color 1 will be, which colors are they mentioning? They are mentioning violet and red. So the color 2 will be violet, color 1 will be red. Okay. But there is some problem with the diagram. They are not showing any refraction here, any bending of light rays here, which is incorrect. The colors still bend when they enter the glass as well. When they enter the glass, they get scattered, and when they get out of the glass, they also get even more scattered. Okay, so diagram 1 is incorrect. In diagram 2, see, they're properly showing that this is bending away and this is going straight. So in this case, color 2 will be violet and color 2 will be red. Now, so diagram 2 is correct and color 2 is violet, color 1 is red. Which option matches our answer? It is C. Diagram 2, color 2 will be violet, color 1 will be red. The question is simple, but often they try to trick you by giving a lot of variations, just like they gave you one diagram here, one diagram here. Most of the students will simply look at diagram 1 and say that, oh, I know this. So this will be violet, this will be red. But you also need to see whether the diagram is correct or not. This section is incorrect. That is why we went with diagram 2 and color 2 will be violet, color 1 will be red. Now, next question. Thermal radiation is part of the EM spectrum. Which name of this region is? Thermal radiation is the infrared region. So answer B will be correct. Next question. A remote controlled vehicle, check it. The vehicle senses an obstacle ahead. It sends radio message to the control room from where it is being controlled. The control room is away from the vehicle and the control room sends a message back to the vehicle telling it to stop. What is the minimum time that elapses between the vehicle sensing the obstacle and receiving the message back? So this is in sort of a echo question. Let's try to solve this. Speed is equals to 2 into distance over time. Speed we will take as 3 into 10 to the power 8 because it's a radio wave. All transverse wave have a speed of 3 into 10 to the power 8 is equals to 2 into what is the distance? 2.4 into 10 to the power 6 over time. So time is equals to 4.8 over 3 into 10 to the power 6 into 10 to the power 8. Now, if we try to solve this, 4.8 divided by 3, it is coming out to be 1.6 into 10 to the power minus 2. So this will be 16 into 10 to the power minus 3. And 10 to the power minus 3 is milliseconds. So 16 milliseconds is the answer that we are getting now. Now, starting with question number 24, there is a remote controlled vehicle. Okay, so you have a remote controlled vehicle. Let's say this is your vehicle, is traveling on a surface of a planet. The vehicle senses an obstacle ahead. So there is an obstacle ahead. Okay, it sends a radio message to the control room. So let's say there is a control room here. It sends a radio message to the control room. So it travels a distance d. The control room is this much away. So the distance d is 2.4 into 10 to the power 6 kilometer. The control room sends a message back. So first the vehicle sent a message which traveled a distance of d. Then the control room sent another message to the vehicle which again traveled a distance d. So what is the distance traveled? 2d. Then they are asking what is the time taken. Okay. So as we know that speed is equals to 2 into d by time, this is similar to a question of echo. Now, what is the speed of radio waves? All transverse waves have a speed of 3 into 10 to the power 8. So I'll write it here. 2 into, what is the distance? 2.4 into 10 to the power 6 kilometers it is, divided by time. So time will be equals to 2 into 2.4 into 10 to the power 6. Now, here is the point that this is in kilometers, but the speed that you take is 3 into 10 to the power 8 meters per second. So, you will have to convert the kilometer to meter. So, multiply by 10 to the power 3 divided by 3 into 10 to the power 8. Now, if you do 2 times 2.4, that will be 4.8 by 3 into 10. So 1.6 into 10, the time is coming out to be 16 seconds. Is there any option matching 16? Yes, option D is the correct answer. Remember one point here, that the distance is given in kilometers and the speed of radio waves is 3 into 10 to the power 8 meters per second. So you have to do the conversion. I converted kilometer into meter by multiplying the value with 10 to the power 3, as 1 kilometer is 10 to the power 3 meters. Okay. So question 24 we have done. The answer will be D. Next question. Which statement about the direction of a magnetic field at a point is correct? It is the direction of force on an north pole placed at the point. This is correct. It is the direction of the force on an south pole placed at the point. Incorrect. It is the direction of force positive charge. Positive charge, negative charge. First of all, they will experience electric field. Then the magnetic field will come. So C and D are out. Answer will be A. Question number 26. Now, this looks like an AC graph, alright. So, what they have done is they have combined AC graph on top of a DC graph. This is your DC, the constant voltage, and this is your AC graph, which is the fluctuating voltage with time, alternating current with time. Now, they're asking that what is W? On Y axis, we always put the voltage. So W should be voltage. It is option C or D. Now we have to differentiate. Which one is the AC supply? AC supply is Y. So this is the AC supply. And which one is the direct current supply? X. So option D is the correct one. W is voltage. AC supply is the one which is alternating continuously, alternating current. So Y is the answer. And X is the constant line. So that is the DC voltage. So that is why. D is the correct answer. Next question. A resistor transfers 100 joule of energy when a charge of 10 coulomb flows through it. What is the potential difference across the resistor? So, we know this formula, that voltage is equals to work done per unit charge. How much energy are you using? 100. And what is the charge? 10 coulomb. So, the answer will be 10 volts. Work done has a unit of joules as well. It is equivalent to energy. So, 100 joules, that is why I am using here. So 10 volts will be the answer. Option B will be the correct one. Question number 28. They're mentioning that there are two wires X and Y made from the same metal. Okay. Length area is given, resistance of one given, and length area of the other one is given. They're asking you the resistance. Alright. So for this, there are multiple methods out there, but we need to be knowing the basic relation that resistance is directly proportional to length and it is inversely proportional to area. So we can say resistance is directly proportional to length over area, right? Now I'll make a formula using this. It's a basic simple ratio. R1 over R2 is equals to L1 over L2 times A2 over A1. Now if you check that resistance is directly proportional to length, inversely proportional to area, both of these relations are true in this formula. Now we simply need to substitute in the values. What is R1? R1 is 2. R2 we are trying to find it out. L1 it is 1. What is L2? 1.3. What is A2? 0.3. What is A1? 0.4. Rearrange the equation. R2 is equals to 2 times 1.3 times 0.4 by 0.3. If you solve this, the answer will come out to be nearly 3.47. So which is nearby equal to 3.5 ohms. Now in case you are wondering how did you make this formula, what I simply did is that let's say R is equals to L by A. So I can say R1 is equals to L1 by A1, R2 is equals to L2 by A2. I simply divided both of the formulas to get the new formula. Alright. Although this formula is not exactly correct, but it gets us the answers. The original formula, as most of you might have studied, is R is equals to rho into L by A. But as rho is constant because it is from a same metal, so I directly removed this and I made a new formula. All of you can simply remember this formula, and any type of question that comes for wires resistance area, you can directly use that formula. Now, next question, question number 29. The diagram shows two resistors uses a potential divider. So this is a potential divider question. For that we need to recall the formula, which is V out is equals to V in by R1, R of that particular resistor, and R1 plus R2. What is V out that you are trying to measure? V in is the one provided by battery. So we are trying to measure this R resistance, and the voltage coming out of it is 1.8. So 1.8 here, battery is providing how much? 3, I'll put 3 here, times the resistance we are trying to measure, so I'll keep it as R, then R plus what is the other resistance? 5. Now we simply have to solve this formula. Now I can say that 1.8 times R plus 5 is equals to 3R. So 1.8 into R plus 9 is equals to 3R. So 9 is equals to 1.2 R. R will be equals to 9 over 1.2, which is 7.5 kilo ohms. Because the R that you used 5 is in kilo ohms, so the answer you will also get in kilo ohms. The answer is C. I'm again explaining this question. This is a potential divider circuit. For that, we need to remember the formula that V out is equals to V in into the resistance of that particular component divided by the total resistance. V out is of that component which they have mentioned is 1.8. V in is the one that you are supplying using the battery. Battery is supplying how much? 3. Then R you keep it as R plus 5. This is how we solve this question. Next question. Two electrical appliances are connected to the main supply. The cable connected to one includes the earth wire. The cable connected to the second one does not include earth wire. Earthing is mainly needed in the appliances which have a metal case. Earthing is mainly required in the appliances which have metal case, just like your electric iron, geysers are there. A lot of devices are there which have metal casing. That is why they need earthing. So one appliance most likely has a metal case, the other one does not. That is why one is using earth wire, the other one is not using earth wire. Do we have an option like that? Yes. One appliance has a metal case, but the other one does not. Option A is correct. Next question. This is one of the good questions. The diagram shows a AC generator. AC generator works on the principle of electromagnetic induction. It works on the principle of electromagnetic induction. No, this is not easy money installments. This is electromagnetic induction. Okay. The magnet rotates around a fixed coil. All right. The EMF output is a sine wave. We are aware of that. AC current is created like this. This is a sine wave. Just like similar to the question we did earlier. That is a sine wave as well. Crests are there, troughs are there, zeros are there. All right. We are aware about this. Now they're showing you 3 positions of the magnet. The coil is same. See, coil is like this. Here it is also like this. Here it is also like this. They're asking that we have arranged it in 3 positions, P, Q and R. You have to tell that which statement about the induced EMF is correct. Alright. So for this we need to recall that when magnetic field is perpendicular to the coil, then most amount of EMF is generated. Because it is perpendicular, so it will be cutting through maximum number of coils. When it is perpendicular, only then magnetic field cuts through maximum coils So maximum electromagnetic induction. So more EMF will be generated. Very simple point. The magnetic field needs to be perpendicular to the coil for maximum electromagnetic induction to take place. The magnetic field needs to be perpendicular to the coil for maximum electromagnetic induction to take place. Now, out of these three options, in which one the magnet is perpendicular to the coil? See, the coil is horizontal, but the magnet is inwards. So, this looks like a perpendicular arrangement. So, most likely, position Q will have the highest EMF. The magnitude of the EMF at position Q is larger than that of the position at P. The magnitude of the EMF at position Q is 0. No, it is not 0. The magnitude of EMF at position Q is smaller. It is not smaller. The magnitude of the EMF at position R is larger than the position P. At position R and position P, it will be the same. They are just arranged similarly. In this, north to south, so magnetic field lines are going left to right. In this, right to left. So it doesn't create that much of a difference. Answer will be A. Because maximum electromagnetic induction will take place. Question number 32. A 24 volt power supply and 100% efficient transformer. So whenever we see 100% efficient transformer, this formula clicks in our mind that power output will be equals to power input. And power output is the secondary side. So VS IS is equals to power input is the primary side. VP IP. I've written P and P in subscript. It represents the voltage of primary coil, current of primary coil. And this represents voltage of secondary coil and the current of secondary coil. Let me write it again. So this will be VP IP. Power output will be VSIS and power input will be VP IP. Input is on the primary side, output is on the secondary side. This formula we are aware about. Now, they have given us the output power. How much is it? 12 watts. So directly they have given you this, which is 12. Primary volts, do we know? Yes, 24. They're asking the current in the primary. So X. X is equals to 12 over 24, which is 0.5. The answer will be A. Okay. They gave us the output power, which is the secondary coil power, which is 12. So we put 12 here. Power input VPIP. So we substituted, we got the answer 0.5 amperes. Next question. The scattering of alpha particles in Goldfall experiment. In Goldfall experiment, which particle was used? Alpha particles were used. What are alpha particles? These are helium nucleus. They are represented like this, He24 2 plus. This is the representation. A nucleus has 17 protons and 18 neutrons. So at the bottom, proton number is written. So 17 is here, 17 is here. And at the top, the mass number is written, not the neutrons. Mass number is 17 plus 18, which is 35. So answer D will be correct. Question number 35. The dashed line represents the decay curve. The count rate includes background radiation. Okay, so this is including background radiation, means you can just assume the sample is decaying at X counts per second. The background radiation adds a 2 to it, let's say. So the graph will always be for X plus 2 divided by 2, then X plus 2 divided by 4. So what you simply need to do is remove the background radiation a little bit, count rate will decrease and it will be like this. Background radiation always adds up to the count rate. So if you have to draw a graph without the background radiation, then you just remove it, value will decrease a little bit. Which option is correct? Option number B looks correct. The original is the dashed line. In option A, the original is the dashed line and they're saying the value has increased. No, you have removed the background radiation. So the value should decrease. Option B is the correct representation. Which type of radioactive source is suitable for use in measuring and controlling the thickness of paper? For thickness of paper, alpha particles are used and the half-life needs to be long. So answer A will be correct. Question number 37, they're asking about the half-life of the source. A medical tracer is used to investigate a tumor in a patient, fine. The graph shows the corrected count rate for the tracer against time, okay. What is the half-life? See, initial count is 10,000. How much time does it take to half? Matlab 5,000, how much time is it taking to go from 10,000 to 5,000? According to me, it is taking around 2 minutes. So the answer will be 2 minutes. Then if they ask you about the second half-life, it is from 5,000 to 2,500. 5,000 to 2,500, so this will be the time taken. The time taken during this duration will be the time taken. The Earth orbits the Sun approximately in 365 days, alright. The average radius of the orbit is Tk. So we know the formula that orbital speed is equals to 2 pi r by time. 2 into 3.14 into radius is 1.5 into 10 to the power 11 meters. Time we will have to take in seconds because all the values are given in seconds. So in 365 days, 24 hours are there. In each hour, 60 minutes are there, and in each minute, 60 seconds are there. So now let's try to solve this complex value. Two times 3.14 times 1.5. This is 9.42 into 10 to the power 11 divided by 365 times 24 times 60 times 60. Very unique number. Let me try again. 365 times 24 times 60 times 60. Why is this showing me different values? Give me 1 minute, guys. 365 times 24 times 24. No. Times 24 times 60 times 60. So they're showing me that 31536 triple zeros. Now, in place of 10 to the power 11, I can write 10 to the power 8 and write 10 to the power 3 here. So from these 3 zeros, we'll cut 3 zeros. Now we have 9.42 into 10 to the power 8 by 31536. So 9.42 divided by 31536. It's somewhere near 0.00029 into 10 to the power 8. So you shift the zeros, the answer will be A. You do the maths, you have the calculator, so answer will be A. Which statement about life cycle of a star is correct? All stars eventually run out of hydrogen as a fuel. This is true in a way. A red giant forms a planetary nebula with a supernova at its center. No, this is not true. White dwarf eventually forms a black hole. This is not true. Majority of the white dwarfs turn into black dwarfs, not a black hole. So this is incorrect. Most stars expand and form protostars. Protostar is formed when the gravity pulls in all the matter together. So it contracts, not expands. D is incorrect. A is the correct answer. Now, question 40 is of our favorite topic, Hubble's constant. Alright, so what is the formula for Hubble's constant? Hubble's constant is h naught is equals to v by d. V is the recessional velocity and d is the distance. H naught is the Hubble's constant, as we are aware. So there is a galaxy at a distance of this much and moving away with a speed of 7,000. The question is asking, first of all, figure out the value of Hubble's constant. Alright, we'll do that. And what is the speed of galaxy when it is this much distance away? So it's simply like this, that there is a galaxy which is away from the Earth. This is your Earth, happy Earth. The distance currently is 3.1 into 10 to the power 21 kilometers. And the speed with which it is moving is 7,000. But after some time, it goes a distance away of 6.2 into 10 to the power 21. You have to figure out the speed. This is what they are asking. So first of all, we will find the Hubble's constant. How do we do that? We use the first set of values given. H naught we are trying to find out. Keep it as H naught. What is the recessional velocity? 7,000. What is the distance at that point? 3.1 into 10 to the power 21 kilometers. So divide 7,000 by 3.1. 7,000 divided by 3.1. It is 2256.06 times 10 to the power minus 21. So you shift the zeros, it will be 2.3 into 10 to the power minus 18. So option A or B. Now we have to find the speed of the galaxy. Now in the second situation, we will again use h naught is equals to v by d. But now the object, the galaxy, is at a further distance, right? So h naught will be the one which we calculated, 2.3 into 10 to the power minus 18. Recessional velocity now we are trying to find. Distance is given for the particular situation, 6.2 into 10 to the power 21. So 2.3 times 6.2, it is 14.26 into 10 to the power 3 as the velocity. So the answer will be nearly 14260, which is coming out to be option number B. Alright guys, this was a good question. Now I'll explain this question again. See, there was a situation first that a galaxy is this much distance away from Earth and it is going away at a speed of this much. So from this, what I did is I found out Hubble's constant, 7,000 over 3.1 into 10 to the power 21. The answer came out to be 2.3. Now in the second situation, the galaxy has moved away a bit. It is now at a distance of 6.2 into 10 to the power 21. As we know that Hubble's constant is a constant, and as the recessional velocity increases, the distance also increases. So the velocity will be different now because the distance has increased. And they were asking the same thing. Now that the distance is increased, tell me the speed of galaxy at this distance. So what I did is, we already know the Hubble's constant. I use the same equation again. H naught is equals to V by D. H naught is given. V will be V and D I'll substitute as the new one. So that is why the answer came out to be option number B. Alright, so we are done with all the questions. In case any doubt is there, make sure to let me know. You can just ask your doubt in the comment section. I'll be more than happy to reply.